Welcome to the Explainer. Okay, let's dive straight into the explosive adoption of AI coding tools and, well, shatter a very seductive myth. We're living through this totally unprecedented shift in how software is written, right? The promise is incredibly appealing. You just describe what you want in plain English, and boom, the AI hands you perfectly working code. But, as we're about to see, receiving working code and receiving secure code are two totally different things.
And that brings us to the million-dollar question we're exploring today. This is an issue that's impacting pretty much every tech org right now, because the implicit contract of just describing what you want and getting code in return kind of ignores a massive threat. Developers are understandably focused on functional requirements, and we naturally just assume the AI is handling the safety stuff under the hood. But if your prompt doesn't explicitly mention security, does the AI still write safe code by default?
To really grasp the scale of this, look at the staggering number. GitHub is reporting that Copilot is writing over 46% of code in files where it's enabled. Let that sink in. AI code generation is no longer this experimental, futuristic novelty. It's literally embedded into the daily workflow of software developers everywhere. So this question isn't just a fun theoretical exercise anymore. It's an urgent, industry-wide reality check. If these tools are generating nearly half of our new code, we desperately need to know what their default security posture actually is.
Now, to get the real truth, we aren't just guessing here. We're leaning on a massive, highly rigorous benchmark conducted by the folks at IO-Active. They went ahead and tested 27 distinct AI systems, spanning everything from commercial giants like OpenAI and Anthropic, all the way to local open-source models. They evaluated these models across 27 different programming languages, using 730 realistic coding prompts. And here's the absolute kicker. These prompts read like normal, everyday developer requests. They didn't explicitly ask for secure implementations. We want to know exactly what these models are doing right out of the box.
So here's our roadmap for this explainer. 1. The AI security gap. 2. Rating the top models. 3. Where does AI fail? 4. Tuning the temperature. 5. The power of prompting. And finally, 6. The final verdict. Let's get right into it.
Part 1. The AI security gap.
When we run that baseline test using those completely natural, non-security-focused prompts, the results are, well, they're pretty concerning. Out of the box, AI models average a failing grade. Across all the configurations tested, the baseline average for generating secure code was just 58.9%. Even more alarming, a staggering 31.6% of all the generated code samples were fully vulnerable to attack. We're talking exploitable flaws with no meaningful mitigation whatsoever. Bottom line, if you're blindly trusting default outputs, you are introducing massive risk right into your code base.
Moving on to part 2, rating the top models. Because that average is so poor, we really need to look at the leaderboard to see which tools are actually going to protect your code. And this brilliantly illustrates just how vast the differences are in the market right now. Sitting at the very top, we have the Codex app, equipped with a dedicated security skill, hitting a really impressive 83.8% security score. Trailing a bit, but still holding strong, is Claude Code at 63.4%. But check out the bottom of the pack. OpenAI's GPT-4o Mini scored just 54.1%. That's an almost 30-point gap between the best configured applications and the worst baseline API models.
What's really fascinating here is the power of wrapper engineering. You might have noticed the winner wasn't just a raw API model. It was an AI-assisted application. Simply wrapping a core model inside an application environment, like adding that specialized security skill to the Codex app, or using the Claude Code CLI, massively boosts your security outcomes. For instance, just using the Claude Code CLI delivers a solid 7.5 percentage point improvement over querying the underlying Claude Opus model directly.
All right, part 3. Where exactly does AI fail?
So, where do these models completely fall apart? The data shows an absolutely wild contrast. When it comes to memory safety issues, think double free errors or buffer overflows, the models essentially performed perfectly. They hit a 100% secure rate. But on the flip side, when tasked with secure authentication, they scored an absolute 0. Nothing. It turns out AI is an absolute perfectionist when it comes to memory management, but it's terrible at guarding the front door. This clearly shows that AI struggles way more with deployment code, infrastructure, and complex business logic than it does with basic syntax. In fact, infrastructure as code was over 20 percentage points less secure than typical AI-generated application code.
Language choice also plays a huge role here. The data confirms that memory-safe compiled languages naturally force the AI to write safer code. When writing in Rust, the models produce vulnerable code only 15.2% of the time.
But the moment you ask them to write in dynamically typed, super flexible languages like Python, that vulnerability rate skyrockets to 43.4%, and JavaScript isn't far behind. Basically, the language you're asking the AI to code in heavily dictates the level of risk you are taking on.
Okay, part 4, tuning the temperature.
Now that we've seen the cracks in the foundation, how do we actually fix this? Let's peek under the hood at the AI's internal mechanics, specifically a setting called temperature. Temperature simply dictates how wildly the AI guesses its next token or line of code. A higher temperature makes the AI more creative and diverse, which is fantastic if you're asking it to write a poem, but potentially a disaster for code. A lower temperature makes the AI highly deterministic and incredibly focused.
And just tweaking this one setting can shift your security outcomes by up to 3.19 percentage points. This proves that temperature isn't just a stylistic preference, it is a vital security parameter. If you're configuring API calls for code generation, dropping that temperature down closer to 0 is a proven, measurable way to lock down the safety of what it spits out.
Part 5, the power of prompting.
Beyond those back-end settings, prompting is obviously the most direct way developers communicate with these tools. We already know that if we don't ask for security, we aren't going to get it. But how exactly should we be asking? Well, the study tested progressive levels of guidance. Level 0 was our baseline, completely ignoring security. Level 3 introduced detailed security principles. Level 4 got prescriptive, literally giving the AI explicit examples of secure versus insecure coding patterns. And Level 5 asked the AI to review and fix its own output. The benchmark definitively revealed that Level 4 is the sweet spot. Providing explicit, concrete examples yields the highest average security gains across the board.
But you've got to watch out for over-prompting, because it's a real trap. Moving from Level 4 up to Level 5, asking the AI to self-review, gives drastically different results depending on the provider you're using. If you ask an OpenAI model to self-review, it actually gets confused and loses 83% of the security gains you just achieved at Level 4. Local open-source models? They completely fall apart. But fascinatingly, Anthropic models thrive on it, continuing to improve by another 5 to 6 points. So your prompt engineering absolutely must be tailored to the specific model you're running.
And that brings us to part 6, the final verdict.
Okay, looking at the big picture for your daily development workflow, here is the harsh reality. No model achieved 100% security, not one. Even the very best configuration we looked at, that Codex app hitting 83.8%, still produced 90 highly exploitable vulnerabilities out of 730 test cases. The final verdict is pretty clear. Human developers cannot abdicate their responsibility. We have to evolve from simply being coders to being strict, uncompromising security reviewers, because blind trust in AI will compromise your system.
So I'm going to leave you with this thought to take back to your teams. Think about your current workflows. Take a hard look at the very last piece of code you or your team merged and ask yourself, who really verified its safety, the machine or you? Thanks for joining me on this explainer, and stay secure out there.